Hello, welcome back. So in this next video of my series on using Amazon EMR, I want to cover another blog post that focuses on using Apache Hive on top of Amazon EMR. So for those who don't know, Apache Hive is a modern distributed data warehouse that can run on top of a Hadoop cluster. And it has an interesting capability in that you can store the data itself on the Hadoop file system, on a Hadoop cluster in a couple of different ways. One is where you let Hive actually control the management of the data. And another is either you can have the data on the same Hadoop EMR file system or HDFS file system, but it can be not under the explicit control of the Hive application itself. Or, in probably the most interesting cases, you can actually have data sets completely external to the cluster. So maybe on S3 or somewhere else, where you just save metadata about that external data set, and then that metadata is used by Hive to formulate a query plan, and it goes out and fetches that data and queries it from whatever external location that is in. And so that's two of some of the really neat things as far as using Hive in the context of a distributed data warehouse. Now, a couple of things worth mentioning about Hive. So Hive is actually just a neat abstraction on top of the MapReduce programming model. So by that I mean you use SQL queries essentially, pretty close to being standard ANSI SQL with a couple of deviations here and there, but you use SQL as an interface language to write your operations that manipulate and fetch, query, massage, whatever, your data, and then that gets internalized by the Hive engine down to a query plan that gets compiled to a regular MapReduce set of jobs that then go out and push data around your cluster, do all of its shuffling magic, applies a series of reducer functions, and then aggregate the results back and present it to you in usually like a tabular type of a format that you would expect from any other regular SQL query. And so, in this blog post that I have here, I start by briefly covering what Apache Hive is and what are its key characteristics and functionalities. And then I get a little bit more specific into how you can use it on a Hadoop cluster or an EMR Hadoop cluster itself. And then, end with some of the more very specific things like running EMR job steps in an automated fashion for Hive batch data processing. So the very first video of this series discusses how to create an EMR cluster with a CLI, with the AWS CLI. So if you don't have one, maybe head over there and create one, or if you already know how to create one and you want to follow along, then make sure you create an EMR cluster that has Hive installed on it. And otherwise just go ahead and follow along with me and I'll walk through some of the awesomeness that Hive offers. So, as I mentioned, not explicitly, but I described, there are two forms of tables within Hive. So there's a managed table where the Hive runtime actually itself can write data and manage its organization on the file system, and that's what's meant by a managed table. So like Hive manages the actual physical data, and it keeps it in a place on the file system right here. So underneath the HDFS file system, actually, under user Hive Warehouse, and then the name of the database, and then each table name is going to have its own directory with data in it. And then there's those external files where Hive doesn't explicitly control the fate of that data and instead just uses metadata that you give to it in the form of a schema definition, which it then uses just the information of that schema to query whatever external data set is available that you point it to. So I have, the ability to zoom in like that, evidently. But I have an EMR cluster with Hive installed on it already, and it's set up as described in that first video of this series. And I'll use this master node URL to SSH onto it as the Hadoop user with the key pair that I also created in the first video. All right, so I'm now on my EMR cluster as the Hadoop user. It's a brand new cluster. I actually just spun it up. It's not the same one as the first video, but it's created exactly the same way. So once you're on Hive, there's a couple of different ways to issue interactive queries. The first of which is just using the actual Hive CLI program, and you can use that by just typing Hive into, at the shell as the Hadoop user. And then you can execute queries in there like show databases. And every Hive instance should come with a default database. So that's actually the context that we're in right now, is the default database. And there shouldn't be any database tables. So if I do show tables, it should be empty. No tables. Now the Hive CLI is, isn't bad, but honestly, the Beeline CLI that also comes pre-installed is a little bit better, in my opinion. The format of the output is more nicely formatted, and it actually executes queries against the Hive 2 server itself, whereas the regular Hive CLI does not. But you have to connect through a JDBC driver. So you'll do beeline-u JDBC Hive 2 / // and then now we're in the Beeline shell. So now if I do show databases, you see it's actually a little bit more nicely formatted, just a little more, appealing and easier to read. That's probably the main reason why I prefer Beeline over the Hive CLI. But use whatever you're most comfortable with. So, similar to other videos that I provided, I'm going to follow along with the blog post that I wrote, sometime in advance before it and published on my blog, The Coding Interface. And sort of use it as my cheat sheet and just understand that, the blog's always going to be there and linked at the bottom of these videos. And really I do these videos just for folks who prefer a verbal explanation and just to see someone working through an active example. So the very first thing I want to do is I want to create a new database called TCI demo. And then I'll switch my context to that database. Well, I guess first I should show. So we now see I have my TCI demo database there, so I can switch my context to it by doing a use TCI demo. And if I show tables in here, obviously, if I show tables in here, it's going to be empty because you just watched me create a brand new blank database. So, I already mentioned that the syntax for Hive QL, which is a variant of standard ANSI SQL, is pretty similar, but there's a few differences, and one of the ones are some of the supported data types. So if I go over to the Hive documentation here, you can see these are the different supported data types. So just in case you're wondering, like, hey, that's may or may not be a regular SQL data type, or where'd you get that information, it's linked to right here in the original blog post. So now that I've got this pasted in here over in the Beeline shell, I'll press enter, and now if I do show tables again, I should see my new table in there. Now you can also describe tables and get their schema back. So let's do describe blog posts. And we can see that I've got all the fields that I defined in my create table statement, and the data types match what I gave it. So there are a number of different ways in which we can load data into a table, because I mean, honestly, that's kind of why we put data into a data warehouse, is to get it back out and to process it in various ways. What I'm going to show first is probably like the most unpopular, or least used manner of getting data into a Hive data warehouse, and that's just doing a manual insert like what I'm showing here. But it's good for experimentation, I guess. So, just like a regular standard relational database insert, you just do a insert into table name, the columns, and then a list of values essentially, right? So if I enter that, it'll take a moment or two to import the inserts, or to execute the inserts and load them in. And one thing worth noting is you can actually see the progress of the actual map and reduce jobs down here on each query. So where that's going to be more explicit are usually on select statements. Sorry, I didn't mean to cut off the top there, but in this query is what I'm doing is I'm doing a count of, or a sum of likes across the different categories that I inserted up here of some more popular blog posts on my blog here. And so we can see here the C++ category actually has the most likes at the moment, and these actually are pretty real numbers from fairly recent polls that I've done. So again, I executed the query, and then Hive internalized it and broke it out into a series of map and reduce jobs, which it then shows me the progress of after submitting the query. And then I get a normal looking query response here at the bottom. Now remember that I said that there's a couple of different types of tables, or table types in Hive. There's managed tables, and then there's external tables. So what I created just a few minutes ago was a managed table. And I can prove that by quitting the Beeline client with a ! quit like that. And then if I peer into the Hadoop file system and do an ls on user Hive Warehouse, which is where Hive maintains the actual data for its managed tables, I can see that I have a tci-demo.db directory in here. And furthermore, inside of that, I should see the blog post directory with the blog post data within it. And so there's my actual physical file there in the Hadoop file system underneath the Hive user. So, what that means is I can actually blow this thing away. So like I could drop the table and the database itself, and then look in this directory again, and it'll be gone. Another way that you can submit queries via the Beeline client is this right here. So notice I'm in just the regular standard shell right now. So who am I? I'm just in the Hadoop user in my normal bash or sh shell, whatever this server has right now. And so I can use Beeline with the connection parameter again, and the -e flag with a series of commands that it'll execute. So this one will execute left to right. Very first thing it'll do is it'll drop my blog post table, and then it'll drop the whole TCI demo database. So if I submit that, it'll take a moment to process the commands that I gave it. And there is a funky thing about the Beeline shell. When you submit commands like this, it'll tell you it's airing out on closing, but if you actually look inside of Hive, establish a new shell connection again with Beeline, JDBC, Hive 2. What I'll see is actually like it did delete everything and execute successfully. I assume this is just some sort of maybe a bug with either Beeline or Hive itself. But if I do show databases, I'm back down to just the default. And similarly, if I quit out of the Beeline shell again, and I do a Hadoop FS listing of user Hive Warehouse. Oops, not warehouse, warehouse. Then it comes back with nothing because I actually really did drop that with that statement down here, like with this drop table and then drop database. So even though that I got that weird error when it closed the connection, it did actually delete it. And actually, I'd love to know anyone that comes across the video and knows why that happens. I'd love to hear from you. Drop a comment down below. Otherwise, we'll just ignore it for the moment. So that's managed tables, right? So again, managed tables just means, the Hive application itself, the Hive runtime really manages the physical files underneath that user Hive warehouse directory. External tables. So external tables are managed somewhere else. So if I make a blog post file, and I'm just using T here to put some direct input in while I did that. So I now have this blog post.csv file. So if I cat blog posts, there's my blog posts. That's the exact same ones that we just did a manual insert with. But instead, what I'll do is I'll import this into the Hadoop file system. So not under the control of Hive, but just in the regular HDFS file system, with this command down here. So I'll make a directory within the HDFS file system called blog posts, and then I'll copy that blog post CSV file from the local Linux file system to the HDFS file system. So now I have it here, and then I will also have it here as well. Then now, when I get back into the Beeline shell connected to Hive, I can create an external table and simply point it. Oops, don't want that. Oof. For whatever reason, that's not letting me copy that. I wish I knew why. Okay, create database TCI demo, use TCI demo, create external table, and I'll throw an if not exists on there, which is kind of pointless for this example, so I actually won't take the time to type it, but it's just kind of a good practice I got into a long time ago. So category is a string, published is a date, likes is an int, title is a string, and then it's row format delimited, so it's stored in rows, and then the fields are going to be terminated by commas because it's a CSV file, and it should reference it from location blog posts. So it'll look at whatever data files are underneath the blog post directory, and why did it get that? So it tells me I'm missing a comma somewhere. Take a look at this again. Ah, I missed the word by here. Okay, let's try that again. So create external table blog posts, category string, published, date, likes is an int, title, string, row format delimited, so store it as rows, not columnar storage or something else. Fields terminated by, make sure I don't miss the comma this time, and reference it from location blog posts. And remember, that's the location within the HDFS file system. So now, if hopefully I can copy from here again and my shell stops being mad. It did, good. Now if I run the same query that we saw earlier, we should see the exact same type of result set. Again, the Hive execution engine is going to take the SQL statement, it's going to break it down into a query plan, compile it to a MapReduce program, execute the MapReduce steps, and I have the same output again. So that's great. So this showed two different ways to build tables within Hive on an EMR cluster. One was a managed one where I actually imported, or actually inserted the data, not really imported. And another was with an external table where I pointed the schema definition to a location within the HDFS file system, and it queried the data set from there. So, what I think I'll do is I'll drop, oh, don't want to do that because I'm actually still within the Beeline client. So let me quit it and then execute this. And so this is going to just drop the table this time and not the whole database. And then there's that weird error that I get for whatever reason whenever I submit the queries with the -e flag. But I promise you, it is actually still use TCI demo as the database and then show tables. So if I run that, we should see no tables get outputted because I just deleted it. And it, of course, still gives me the error because it's throwing errors when you disconnect, but tables are gone. And so what I think I'll do is I'll break this video up into two parts. And in the next part, I'm going to talk about how we can actually save our SQL queries in files and execute the files against Hive, which is a much more realistic way of working, where you write your code, save it to a file, and then execute it over and over to do repeated analysis. So I hope you found this very introductory portion helpful if you're not used to Hive. If you do know Hive already, then hopefully sitting through that wasn't too bad. In the next section, like I said, I'll show you how to execute HQL scripts with the Beeline client. And so if you have the time, please join me in the next video. Thanks.